Okay guys, we're going to try this. We're going to solve some trigonometric equations. You got a test coming up January 10th. There you go. Before we solve some trigonometric equations, what I want to do is I want to kind of look at what the functions for sine and cosine look like. So let's just do a quick little review here. If I were going to graph, just going to sketch a little cosine, okay? Sketch a little cosine. I'm going to do it up here. There's my cosine curve. And I know the period for cosine is 2 pi. I'm going to draw my y-axis. I'm going to draw my x-axis. And since the period for cosine is 2 pi, I know that this is 2 pi. I know that this would be 4 pi. I know that would be 6 pi. I also know the max is 1, and I know the min is -1. And again, this isn't drawn to scale, but it's sketched. Okay, so it's just all we want to be able to do is just look at it and see what it is. So let me just sketch real quick a sine curve. So I'm going to sketch my sine curve. You can see I'm not doing it's not as tight when I draw it. I don't know why. It's just how I drew it. Then I'm going to put in my y-axis and my x-axis. Again, not a great drawing, but just enough that I can see what's going on so we can talk about it. There's my y-axis. There's my x-axis. Okay, so what I want to look at here, let's look at the top when we're talking about cosine. If we were asked to solve an equation that said cosine theta equals 0.6. So what we would do is we would say, okay, this is 1, so that's halfway, so it's a little bit more than halfway, and we'd draw a line. And we would look for the places of intersection, because where that line intersects the sine curve, that would be where our solutions are. How many solutions are there? Yeah, there's a lot, because that line keeps going forever, and so does that curve. So there's an infinite number of solutions. But the problem is, we don't want to have to write them all. We'll never get done with that problem on the test if we have to write them all. So what usually happens is they restrict our domain, and they say, hey, you know what, I don't care about all of it. Just tell me the answers that are between 0 and pi. Well, how many answers are between 0 and pi? 1. Right. Then they'll say, okay, you know what, never mind. What I want you to do is, instead of just telling me the answers between 0 and pi, I want you to tell me the answers between 0 and 2 pi. Now how many solutions are there? 2. Okay, I want you to give me the answers between 0 and 4 pi. 4. And they'll play with you like that and have you write them. Or what they'll do is say something like, write the general solution, so that anybody anywhere could calculate for the whole domain, for all real numbers. So if we actually look, this first question that I've just given you is the first example, and it asks us to solve the cosine of theta equals 0.6. So if we did that, the first example says to solve between 0 and pi. So again, we said we can do that because there's only one solution. If we remember when we graphed the inverse cosine function, the inverse cosine's range is between 0 and pi. That's what we want. So we can just type this in our calculator. When we solve this equation, we have cosine theta equals 0.6. I want to get theta by itself. I want to find the angle. If I'm trying to find the angle, that means I've got to do the inverse of the cosine. So I'm going to do inverse cosine of 0.6. I type that in my calculator, making sure I'm in radian mode. And when I do that, calculator, mode, I'm in degree, I need to switch it to radians, come down, second quit, second cosine, 0.6. My answer is 0.927295. It wants it to the nearest thousandth, so that means that my theta is 0.927. And I'm done. I have solved this equation, and I have found that this point right there, that solution is 0.927. You're like, Finn, this is easy. Why make it such a big deal? Well, if you read the next question, or you turn your box over, you'll see that it's now asking you to solve the equation when theta is between 0 and 2 pi. So that's changed our little window here. So instead of it being here, we're going to there. So how many solutions do we need? We need 2. We got our first one. And really, that's the only one we're going to get because our calculator is going to give us the answers between 0 and pi. So we have to use our brain to figure out how to get that one. So, well, if I know that the cosine of theta is 0.6, and I know that the cosine of 0.927 radians is 0.6, what other angle has the same radians or has the same cosine? Well, you're right. On the other side of here, it's negative. True? But I don't want that one. I want this one. So what we're going to do to get that one is we're going to take 2 pi, because that's the period, minus theta. So to find this second answer, we're going to do 2 pi minus theta, which would be 2 pi minus 0.927, which is going to be 5.356. So that's another possibility for theta, because we have this 0.927 and we now have this one, which is 0.927 short of being to pi. Okay? Now what if they said, hey, go to 3 pi? How would we find this one? Yeah, the period's 2 pi, so we would just add 2 pi to that. If they said to go to 4 pi, we would just add 2 pi to that. If they said to give the general solution, what would we do to each of these to get all the solutions? We would add 2 pi, because that's the period. So when it asks us in the next question to give the general solution, to write the general solution, okay, so if we want to write the general solution here, what we're going to do is we start with our 2 answers, one, which was 0.927, the second, which was 5.356, and we're going to add 2 pi to it. But we can't just add 2 pi once, right? Because you may want to go for infinity. So we have to add some kind of multiple of 2 pi there. Anytime we want to do a multiple, we just slap a k there and tell everybody that k is an integer. Because what that does is it says, hey, if Madeline wants to go to 8 pi, she can put a 4 there and it'll work. Okay, so you can calculate that way. So let's try this one. If we look at the sine curve here, we're going to solve it the same way. The only difference is this is in degrees. So let me just go real quick and change my calculator into degrees. Mode, degree. Okay, so I've got to solve this and get the sine part by itself. So the sine of theta is 0.23. And since I'm looking for the angle, that means I'm going to be doing the inverse sine of 0.23, which when I type that in my calculator, second sine of 0.23 is 13.297, which is 13.3. So that's the first answer. So let's go back to our sketch, and we're looking at sine this time. So our first answer is right here, because it's like 0.23. I made that up a little too high. So if that's 1, then this is a half, so it's probably like down here. So this would be 360 degrees. And this would be 720 degrees. And then this would be 180, so forth and so on. So we know that this one, this solution here, is 13.3. How do I find the next solution? I'm not going to subtract it from 360 because I don't even have to go the whole way to 360. What am I stopping short of? Well, I'm stopping short of 180. So what does that tell me about these two angles? They have to be supplementary. So to get this angle right here, we're going to do pi, if we're in radians, minus theta. Or if we're in degrees, as we are here, we're going to do 180 degrees minus theta. That's how you get the second answer. So if we go back to this, to get our second answer, we would do theta equals 180 minus 13.3. So our second answer would be 166.7 degrees. These would be our two answers. They're not asking us for general solutions, they're just asking us for those two that are between 0 and 360. Same thing here. You start by dividing by 4. Cosine theta equals 0.15. So we do the inverse cosine of 0.15. I think it's 81.37. I think I've done this enough times in the last couple of days. But second cosine 0.23. No, it's not 0.3, it's 0.15. 81.37. So we're at cosine. So if we think back to what their graphs look like, for cosine, the first one's 81, so it's here. Where's the second one? Well, it's short of 360. So to find our second answer here, we're going to do 360 minus 81. And we get 278.63. And that's our second answer. Okay? Those were pretty easy. Next one, let's try that one. I'm just going to switch my color. I'm tired of blue. Subtract 3 from both sides. So 5 sine theta equals negative 3.8. Divide by 5. So the sine of theta is negative 0.76. Uh-oh. You're probably asking yourself why I said uh-oh. You'll see. So when I type this in my calculator, sine's negative. When the sine is negative, the inverse sine function gives a range of negative 90 to 90. So when I type in negative 0.76, my answer is going to be negative. And I got negative 49.46. So that tells me what theta is. But that's less than 0. I want my answer to be between 0 and 360. All right, well, let's go look at our graph. So if I go back and I look at my graph, negative 39 or 49.6 is somewhere over here, right? I want to move it to here. So how do I move negative 49.46 to here? Yeah, you just add 360 to it. So we go back, and we're going to take that negative 49.46 and we're going to add 360. So that tells me that my first answer within my domain is 310.54. Now, I still have to find that second one. Now, if you look back at your graph, what you'll see is we found this one. We need to get this one. And remember how we did it before is we did 180 minus our first answer. Well, our first answer was negative 49. That's okay. We can still do that. So to find our second answer, we're going to do that theta is going to be 180 minus negative 49.46. So we're really going to get 229.46. And those are our two answers. We want them to be between 0 and 360. See, I almost circled the wrong one there. Okay? So that's basically what you got to do for these. If you're struggling, please come see me. I know some of these I'm not going to take the time to put the practice problems on the video, because to be honest, it's getting kind of late, and I'm showing them to you in case you want to try them, and then come check with me and see what you get. Okay? Thanks.